So you have a really awesome Unreal Engine 5 project that looks great in viewport, but now we need to convert that into something that is usable, like a high quality still shot rendering or a really sharp looking cinematic animation. But sometimes it can seem confusing how to get from the viewport to the finished result. Well, don't worry, in this video we're going to discuss all the settings you need for perfect renderings. How to get from point A to point B. And it's actually quite simple. There's just a few principles that you need to understand. Let's jump right into it. First things first, when it comes to render settings, we obviously need a camera. Let's find one of those first, and then we'll need a level sequence that controls our camera and the things going on in it. And it's the level sequencer which we will eventually use to actually render. If you already have a really good handle on cameras and the level sequencer, now is the time to skip ahead using the chapters below. Otherwise, let's continue. Let's just say we want this view right here. So we go to the three bars up here, we say create camera here, Cine Camera Actor. Now let's set up a level sequencer which essentially acts as a scene state for this camera. Everything we want to see through this camera can be controlled using the level sequencer, and let's consider that part of our render settings because that's how everything is going to look through our camera. The way that I add a level sequence is by creating a level sequence folder in my content folder, going into here, and then just saying add cinematics level sequence, and I will name it ls test 2. Then we just go into this level sequence, and it's not actually doing anything yet. We need to add our camera to this level sequence. So we have Cine Camera Test right here. Now it will automatically add a camera cut for you, and if you don't have the right camera cut that's associated with the camera you want to render, you can add it right here. We can also set our range in here. Let's treat this one as a still shot. Just a quick rundown of how the level sequencer works. We have our working range start and our view range start. And we have our working range end and our view range end over here. Okay, when this first opened, it was set to render 1,000 frames, and we could animate in those 1,000 frames. But we can change that by dragging this red line to whichever frame we want the animation to end on. So now the animation is 7 frames, 1 of 7. We can drag it back to here at 1. Now it's just 1 frame, so when we're rendering it as a still shot, that's what we would want. Our working range and our view range are both at 0. Our view range here, we could end it at 2. Working range is 1,000, but we can't see that far unless we stretch this out. Okay, so this is basically how it all works. And then our cut is which camera we want to see during this 1 frame. And if we deleted this cut and then added it back in, for the Cine Camera Test, our camera that we want to render, it would just fill in the total animation time. You can also drag these cuts to be longer or shorter. So if it comes in at 1,000, you can drag it down to 1 if you want. And you can also change your overall animation, dragging this red bar to frame number 1 as well. So now we're set up for a single frame rendering for a still shot. We will look at how to do it for an animation later, but it's closer to how this opened up by default. Okay, with our camera cut set up as a single frame, we can adjust anything we want on the camera. You can see that with the camera in here, we automatically have the focal length as part of the adjustments that are available, but we can also add any other element like post-processing settings, exposure compensation. Okay, so any settings on that camera can be set via the level sequencer. If we wanted to change the time of day, we can also do that by adding the sky actor to this level sequencer. Mine is the ultra dynamic skies. I can go to time of day under basic controls, and then I can adjust that here. And since this is a still shot, we're not going to keyframe it, but you can keyframe it using these. So it can change as your level sequence goes on or plays. We're not going to get into the ins and outs of animating using the level sequencer because here we're just using it as sort of like our scene state, which goes hand in hand with the render settings that we're going to see in a moment. Okay, so far we've really only talked about level sequencer, and that's not exactly render settings, but it is the foundation for what we're going to render. Now we need to add this level sequencer to the movie render queue, and that's where we will look at the exact render settings we need to make the level sequence render properly. So let's check that out. So we go to here, Window, Cinematics, Movie Render Queue. Then we can add our level sequence right here. This one is called Test 2, right there. And we can turn it on and off here. We can add as many or as little as we want. And then our settings for them are going to be here. And this is the output it's going to be set to. So let's get into what the settings should be for this still shot. Okay, when we first go into the settings here, we'll see everything looks pretty basic, but there are some default things here. By default, we're exporting to a JPEG sequence. And we can go into most of these and adjust settings. Here's our output. This is important. This is where we tell it where to save. This is also our resolution. We can use custom frame rate. Okay, so whatever your final frame rate wants to be, you can set here. And here we can also use the custom playback range. So by default, it's going to render the number of frames we have in our sequencer. If you remember, we have this green line at 0 and this red line at 1. That means our whole sequence is only 1 frame, and that's what it's going to render by default. But we can do a custom playback range. Say we had 1,000 frames of animation in there and we only wanted to do 1 through 200, we could type that in here. So this is just basic output stuff. So how do we do other settings? This doesn't seem to cover everything. So if we go here, we can add in all sorts of different other settings. You can see here's the different types of exports we can do. The JPEG sequence is default. You can do other types of sequences here. I usually leave mine at JPEG sequence and then take it into something like After Effects or Premiere later for editing. Lots of different kinds of renderings you can do here, including the path tracer, which we will look at. But these are the most important things up here. These are the kind of things that we will need most often, especially anti-aliasing. So let's add that one. In anti-aliasing here, this gives us the chance to really up the quality of our renderings. This sets how many samples we will be doing per frame to make it look smooth, to make it look clean, to make it look high quality in general. For a visual example, this is 1 sample and this is 32 samples. There is spatial sample count and there is temporal dealing with time. So if you have movement in your animation, which you should, otherwise why is it an animation? You should be using temporal sample count. This will add your smooth motion blur and other things like that. But at the same time, it will also be making your edges clean and not sharp. It will do all the things that anti-aliasing wants to do. For a still shot, you could theoretically just use spatial sample count, which will basically do the same thing, except it will not take the frames before and after the current frame into account. Keep in mind that if you use both of these, they multiply by each other. So if you have a temporal sample count of 8, for example, and a spatial sample count of 2, it will take a total of 16 samples to render 1 frame. And you'll see when you render, it'll do 16 frames before it renders the single output. And this gives you more information about that down here. In the case of an animation, we can just leave this at 1 and simply focus on the temporal sample count, which could be 8, could be 16, could be 32. You can see down here it gives you a note that this sets it to 16, and this is greater than the number of TAA samples controlled by one of the console commands. So what we need to do in that case, or really in any case when we're doing anti-aliasing, is override the anti-aliasing set in the scene and just set it to none. That way these controls control everything about our anti-aliasing. Here you can also render warm-up frames, which gives the temporal anti-aliasing time to take into account frames before it actually starts rendering. So motion blur takes into account frames before and after the actual frame you're rendering to get the proper blur. Warm-up frames can help you do that for frame number 1. Also, if you have physics simulations that you want to already be simulating when frame 1 starts, warm-up frames can help with that too. And here's a little secret for you. With just these settings, you are going to get good results. All you really need to do is mess with the anti-aliasing, override the default anti-aliasing, make sure we have a good number here, and it might take some trial and error, but this will give you good results. And this is the main control we want for quality on our images. With a still shot, we can go even bigger. And since we're doing a static rendering here, let's just say we'll do 32, static rendering, make sure our output is set somewhere where we want it. Let's set it to bigger. We'll set it to 4K. set a folder where I want it to go, and just hit accept. Okay, now that is all you need to do. You can save this configuration and then you can apply it to all the stills you have if you have the same settings for all of them. Just as an example, if I put this in here, I could save this configuration, save as preset, still shot, accept it, and then I can load it again here, and it will apply the same exact thing to any level sequence I want to, which is great. Keep in mind it applies the same output as well. Yeah, but I'm not going to render that one. Side note, you can also save your entire queue here, which I find to be very useful. If you have everything set up, you can save it as a queue, and then you can change all the settings using these presets here. It makes things a lot faster and more efficient. But this one's ready to render. Let's just hit render and see what happens. It crashed my computer. That sounds about right. Okay, so that did crash my computer, and it didn't have to do with resolution or anything like that. It's just rendering one frame with 32 subsamples. That's all fine, but this will happen a lot, and it's hard to know why. But this is good because it brings up more render settings that might be important to your rendering. If I look in here, you can add more settings that might help. In this case, I went to here and added the game overrides settings, which can be found right here. Now, when I go into them, there's one key thing in here that helps my computer not crash for this particular rendering. And the reason is because it has a ton of foliage, but more importantly, a ton of landscaping grass. Okay, and this setting right here, flush grass streaming, is set to false now. It was set to true, and that's actually what crashed my computer. If you look at it, what it does is it prevents visible pop-in culling of grass instances. So like if you're animating across a large grass field, you'll see as the grass gets farther away from the camera, it'll be popping in and out or disappearing. But flushing it kind of loads all of it before you start rendering, so you won't have any of that popping in and out. But on a huge scene like this, that's going to crash your computer. So I just turned it off. And how you address that, well, you can do it with various different things. But as far as render settings go, turning this on and off might have a big effect on getting your renderings to work properly. Okay, so in my case, that's what was going on here. You can also do things like disable HLODs in here. And these are the things I might adjust. There's various different problems you might have by rendering that may or may not be able to be fixed via the game overrides here. And of course, each one of them gives you a tooltip when you hover over it. Okay, so for this still shot, this is ready to render and it will work this time. And as you can see, there really isn't a lot to the render settings. It's mostly making sure everything's going to work using the game overrides and then setting your anti-aliasing to determine what quality and then your resolution and so forth. And this will apply to both path tracer and animations too. We'll look at those in just a second. There's some slight differences, but other than that, all these same principles will apply. Let's look at the results of this rendering. First, with no anti-aliasing at all, then with our good anti-aliasing settings, and then with some fancy Photoshop tricks to finish off the post-processing. Okay, so we've seen a basic still shot rendered out, and the difference in quality isn't really showcased by that image. So I want to look at some other images that really showcase the difference we're getting here using essentially the anti-aliasing. So in this scene here, I'm going to do a quick animation and we're going to render it out, and I'm going to exaggerate the depth of field and the motion so that we can really see what the anti-aliasing will do for us. It should really showcase it. So let's just set a keyframe here for the location of this camera and then go 150 frames and let's see how that looks. So if I play that, yeah. Okay, so 150 frames just moving in towards the house. Something a little more architectural here, but also all this stuff in the foreground will be blurring as I go. There's a lot of contrast between the trees up here and the sky. That is hard to get looking really nice because it'll look too sharp and jaggy and have artifacts unless we have our settings right. So this will be a good one to showcase. Let's render this the same way we rendered the other, but this time setting our frames from 1 to 150 instead of just frame 1. So I'll render this in the movie render queue and we'll see how it looks to really showcase how we would do this with animations. And again, it's the exact same principles, exact same settings actually, but this time we set the frames from 0 to 150. Everything else will be the same as we've shown before. Let's check it out. FYI, I'm going to go with 16 temporal sample count here for this animation, and we'll see how it works. Okay, I went ahead and rendered this animation, this quick animation, as an example with anti-aliasing set to temporal 16 and then with no anti-aliasing at all, and we'll see the difference here. So you can see in these leaves, anti-aliasing will be particularly important in blurring. So you can see that there's really nice, clean blurring going on here. And it's also very important in these high contrast areas, like where these leaves hit the sky. And you can see this blurring is really nice in the foreground, and this edge is really, really clean. In the back, you see some jagginess, so we could probably go even higher. This is very hard for anti-aliasing because it's so small and so much contrast. But we could probably go even higher there. It looks okay, but could be better back there. The foreground looks great. If we play this, it looks like this. So the overall effect is that it's smooth and nice. Without any anti-aliasing, let's see how it looks. So you can see it's struggling in any of these fine detail areas. You see some things dancing around. The trees look like they're shimmering or dancing. All the high contrast areas look terrible. Let's zoom in and look at some of this. So you can see there's a perfect example right there on this tripod. The edges look really, really bad. There's some dark edges, all really bad. If we turn this back on, it looks like that. Let's look at the leaves in the foreground, the blurring that's happening here. Okay, so that's the difference. As we get moving here, everything looks nice and soft with the anti-aliasing on. Without it, it's all jaggy. Really, really bad in this area. So this is a great example to show the difference between nicely anti-aliased versus not. No dancing trees. Everything looks clean. Very good. Just keep in mind that this had to render essentially 16 samples per frame, and the other one was rendering 1 sample per frame. So the render times are going to be significantly different. Okay, now let's take a look at how we would render if we want to use the path tracer. Let's go to path tracer real quick. And you can see that it's kind of working itself out here. In this case, we're just rendering a still shot. Let's go into the camera settings of that still shot and search for path tracer. These same settings can also be found in the post-processing volume. Now with these settings, the important thing is the samples per pixel. This is equivalent to the anti-aliasing samples that we were setting in the movie render queue. So turning this up and down gives us more or less samples. Right now it's working on 1,000 samples, and it's refining itself slowly to give us a finished image. But if you let this red bar run all the way through, that would give you a good preview of what 1,000 samples will look like when we go to render it. The other thing to worry about here is the max path exposure. If we put that up to like 30, you can see all these fireflies. That means some of these pixels are getting way overexposed and creating these huge blooms. To avoid that, we can just turn down that max exposure. I set mine to 10 and it got rid of them all. The other thing is the denoiser. We can just disable that altogether. If we turn it on, then this will attempt to get rid of the noise by kind of smoothing everything out. That has a tendency to make everything look too smooth and kind of jumbled together. You lose detail when you do that. So I'm going to leave it off, and that will apply when we render as well. Okay, so this camera is all ready to set up in the movie render queue, just like before. I've already set up a level sequence for it. So if we go to movie render queue and add it, let's just look at the settings here. Now for rendering, instead of deferred rendering, we can just delete this. We want a different kind of rendering here, and it is a path tracer rendering. We can just use this as default. We could turn this on and off if we have some major motion blur going on in your scene to try and get the best results. This affects the way that the anti-aliasing will happen depending on things moving in your scene. But aside from that, all we really need to do is, again, our anti-aliasing settings. Here, the spatial sample count will be the same as the sample count that we were doing in our camera settings. So if we set this to 1,000, it will be the same thing that the viewport was trying to show us. I think that should be enough. It might not be. It depends on how much noise you want. We turned off the denoiser, so there might be some noise in this. I don't mind a little noise, but if it's too noisy, we would need to turn this up and render again. In this case, we have multiple frames in our level sequence, but I only want to do one, so I'm going to just render a custom range of 0 to 1, and that's really it. Path Tracer should work just like this. The only thing we really need to pay attention to is our spatial sample count here. Of course, the temporal sample count will matter if you are doing an animation or if you want to see motion blur in your stills. Then all the principles that we talked about before will apply. So you could use spatial sample count to get the overall quality and get rid of the noise, and then you could use some temporal for the motion blur, but remember they multiply by each other. So whatever your total, if you wanted 1,000 total samples, you could put this at 5 and put this at 200. That would give you good motion blur and good overall anti-aliasing in the case of the Path Tracer. In this case, I'm just going to go all spatial and then just hit render, and we'll see what we get. It's going to take a minute because this is actually path tracing and it has to do 1,000 samples, and it will take a little bit of time. Okay, so here it is with 1,000 samples. It's a little bit noisy, but I think it looks pretty good. And here it is with some mild post-processing. If you want to refine this more, you know what to do. Just turn up those spatial sampling numbers. Okay guys, that is pretty much it on the render settings. Obviously the most important thing is those anti-aliasing settings. That just controls the quality of your renderings overall. If your renderings are working, just change that up and down for faster renderings or higher quality. That's kind of the secret to all this. Okay, I got a little long-winded, but I tried to cover a lot of different things in there, problems you might run into. Hopefully something in here is helpful for whatever you're trying to render. Obviously there's more to the overall process. I'm going to add some videos for the post-processing part in the YouTube extras area of my website, which is part of my membership tiers. Also, if you join the higher tier there, you can get my full Unreal Engine course there, where we go through an entire project with all this different stuff. But if you don't need any of that, the best way to support me is just subscribe. I've got a lot more videos about UE5 coming up. If you haven't seen the full cinematics and the making of video of this particular project of Hyrule Castle, make sure to check that out. And there's a lot more videos coming in relation to that project coming soon. Make sure to subscribe so you don't miss any of that. Thank you so much for watching, and I'll see you in the next video.